Hello everyone, my name is Abhi Bhardwaj. I'm back with lecture series on science. Today's topic is going to be climate change, and I'm going to discuss about paleoclimates. So we're gonna look at what happened in our Earth's history when the when global warming happened, and what it led to in the past. So let's get started. Quickly see what are the different time periods. I'm going to discuss about one specific period in our history, which is called Permian age. And during that time there was a mass extinction of living animals on this planet. About 97% of this ocean life disappeared during that period suddenly, and also about 70% of the land animals disappeared, and about 83% of the insects disappeared. So suddenly all this happened. It almost wiped out the entire life on this planet. And so let's find out what went wrong and what lessons we can learn from the history and apply those in our current computer models to understand our future of our planet. So let's get started. When we look at, say for example, if I go back into the history of Earth, we all know that Earth was formed about 4.6 billion years back. And I'm gonna start because the from the period we have basically the fossil records also. So let's get started from 650 million years back, and then go here 550 million years, and most of the history is in million of years. So that's how you see when you learn earth science. So say 650 million year was Precambrian period, Precambrian, and then you had Cambrian here, which was 550 million years. So then Ordovician, Silurian, Devonian, Carboniferous, and then Permian. This is, going to put it in capitals so we remember this. This is what we are going to discuss. This is our topic today. And then we have Permian, Triassic here, and Jurassic here, and then it keeps going, but I'm stopping here. So basic idea is to learn about Permian. This is the period when it happened. It happened about, so Permian was from, I would say, 299 million years to 250 million years. So between this period was all Permian. And this is the period when we saw, what did we, when we say, all the paleontologists and paleoclimatologists, basically when they look at this period, but by looking at the fossils we find, and also carbon dating, and finding the age of those fossils by different methods, what they find here is that 97% of ocean life disappeared or went extinct. So I'll say here, disappeared, went extinct. 97% ocean life went extinct around 251 million years back suddenly. So what went wrong? We're gonna find that out. So 97% of the ocean life here, and land, 70% land animals also went extinct. Okay, and then insects, about 83% extinction. So we need to know what happened. This is almost wiping out entire life on our planet, and this needs to be very carefully examined, understood, and applied to our current problems. So let's see. So main culprit they found out was, again, CO2. Carbon dioxide level went up 900 parts per million. So this is the culprit, and the reason for that, so when you look at the different studies, they found out and reached to the conclusion that At the time, there were a lot of volcanoes, so a lot of volcanic activity happening, and they were releasing a lot of different gases, including CO2 into atmosphere. So that activity, you know, suddenly went up because of the different volcanoes on a planet, and this led to rise in CO2 level in the atmosphere, which led to rise in temperature, and main culprit was rise in temperature, right, because of CO2. So exactly what is happening right now. Now, how do we see, what still we have to still find out, how did this all 97% of, how did it affected oceans, especially when we look at 97% of the life going extinct suddenly. So see, when you look at, say for example, CO2 going level going up, now you look at the oceans here. So this is, for instance, ocean here, right? And this is the floor of the ocean. So what happens when the temperature starts rising? So CO2 leads to greenhouse effect, which leads to rise in temperature, right? All of us know. It starts to rise the temperature of the oceans, right? And what happens when the temperature of the ocean starts rising? As we have mentioned in other lecture, the methane, which is, being produced by methanogenesis in the oceans, from decomposition of the organic matter here, starts getting released. So methane starts getting released into the atmosphere from the oceans, and methane, we know, is 25 times more potent gas than CO2. So when this comes into the atmosphere, it increases, it accelerates the warming effect and accelerates the rising of the temperature. So the temperature will start rising much quickly, much faster when the methane starts getting released from the oceans, right? So that's what happened. And what other factors were there? So when you look at, for instance, when we drink soda, how do we drink it? Cold, right? Why? Because the gases are entrapped in the cold soda. But do you drink ever hot soda? Because there's no gas in there, right? So remember, when we raise the temperature, the ocean starts losing its gases. Which is the one most important gas in the ocean? Is oxygen. And all the animals use that oxygen, right? So we start losing oxygen. What happens in the ocean? Acidification leads to sudden acidification of the oceans, right? And what that leads to, animals going to start dying because they are now starved of the oxygen, right? So there's no oxygen, and the ocean is more acidic, right? So it's getting more and more acidic. What other factor happens with that? There are bacteria which live without oxygen, right? In the environments where there's less oxygen, they thrive. They thrive. And what do? They decompose the organic matter, which is dying now. What it leads to? Formation of another gas called H2S. And H2S is poisonous, so it's gonna kill all the animals within the ocean. And when it comes out, it starts affecting the land animals as well. So this is what happened. The land animals also went extinct, 70% of them, because the ocean had a major impact on them as well. When the acidification happened and all these bacteria were producing all this gas here, this led to now affect animals as well. Other factor was, see that when I said insects, so insect went extinct, 83%. And what it leads to, all the flowering plants depend on insects, right? So those are gonna go extinct as well, or they're gonna die as well. And that is exactly what happened in that time. How we can learn from Permian extinction to the mass extinction in our history of our planet, how we can learn and apply to current problem. So when we look at carbon dioxide levels, now we are already 400 parts per million. Already there in 2016, a little bit more than 400, right? And this is a steep rise, say from 1890, which was around 290 parts per million, to now, in 126 years, we are already, 400 parts per million. It has led to 1 degree Celsius in rise already. 1 degree Celsius has gone up. What is this doing to our oceans now? It's warming up the oceans. What it can lead to is, release of this methane gas. Other factors. You look at the North Pole, right? This is all permafrost region. right? It has also a lot of methane entrapped here. Same thing in Antarctica. Lot of methane has been entrapped here. When you rise the temperature, the ice starts melting, you start releasing methane here in the atmosphere as well. What would that do to current situation? Methane is 25 times more potent, means it's gonna lead to quick rise in temperature now. 2 degrees Celsius, 3 degrees Celsius, 4 degrees Celsius, so on. So we are kind of reaching that stage. We are and if we do not stop these greenhouse gases, there are other ones. For example, you have carbon dioxide, you have methane, which I said, nitrous oxide, CFCs, and all others. So basically, what happens is that when you do not control these, for instance, right now the CO2 is playing havoc on our planet, right? And if we do not stop that, then we're gonna lead to the same problem what we had in Permian period, where there was a mass extinction. And then we have seen again that in Paleocene you've seen thermal maximus, which I have discussed in other other lecture as well. But when you look at that, PETM, similar events happened at the time also around 55 million years back. But this was the worst one. This almost wiped out the entire life on this planet. And we actually can head towards that if we do not pay attention to what we are doing. And this needs to be done at a war footing, around the globe. Every leader has to stand up and say, stop. And make rules, very stringent rules, that we stop introducing CO2 and other greenhouse gases into our planet as quickly as possible, because we're gonna be otherwise riding the death sentence for humanity, but not only humanity, the rest of the life also. And I think this time it's not volcanoes, it's not meteoroids, it's the humans. This all problem which we see currently is human induced problem, and humans has to stop it if we want to use this planet for us and for our coming generations. We need to take that decision now, and we have to make sure that we reach out to every leader. Each country, each community can go to their leader and talk about this, and make them stringent laws so that we stop this menace from happening. If we do not stop it, we can definitely know where we are heading to then. We have seen that happening twice in the Earth's history. And at that time there were no humans. This time there are humans, this is human induced, and we're gonna be responsible for our activities, and in the end might go extinct as well. Thanks for watching.